Bismillahirrahmanirrahim. Today we will perform an experiment on differential amplifiers. Remember that the first stage of every operational amplifier is a differential amplifier. Now you people know that operational amplifiers are linear ICs that can be used to amplify signal frequencies that extend from 0 Hz to well above 1 MHz. We know that operational amplifiers have two input terminals and one output terminal. One of the most important qualities of an operational amplifier is that it amplifies only the difference between its two input signals, while rejecting or severely attenuating signals coming to both the inputs, common to both the inputs. This allows operational amplifiers to be used in systems where a large amount of electrical noise is present. So in this case, the desired signal is amplified while the noise common to both the inputs is attenuated. So the differential amplifier is a special amplifier that amplifies only the difference in two input voltages. So in this experiment, we will perform tests to determine the differential voltage gain, the common mode voltage gain, and the common mode rejection ratio. So this is actually our circuit diagram which represents the differential amplifier. Here we have two BJTs Q1 and Q2. Here we have two input terminals, one terminal and the other terminal. So the base of Q1 is actually called the non-inverting input, whereas the base of Q2 is called the inverting input. Similarly, we take the output from any one of the collectors of Q1 and Q2. It means that we can take the output from here as well as we can take the output from here. So a differential amplifier has two input terminals and an output terminal. And a differential amplifier is a special amplifier that amplifies only the difference in two input signal voltages. It means that अगर हम यहाँ पे voltages अप्लाई करते हैं, input voltages अप्लाई करते हैं, तो जो output हमारा आएगा, that this amplifier will only amplify the difference between the two input signals, and we will get the amplification at the output, and we can take the output from the collector of Q1 as well as from the collector of Q2. तो हमारे पास दो इनपुट टर्मिनल्स हैं और एक आउटपुट टर्मिनल है. Now, how can we determine the differential voltage gain? For the differential voltage gain, we have to apply the input signal at any one of the terminals while grounding the other input terminal. It means that कि अगर हम voltage signal Q1 के बेस पे अप्लाई करते हैं तो जो Q2 का बेस है वो हमने ग्राउंड करना होगा, और अगर हम Q2 के बेस पे सिग्नल अप्लाई करते हैं तो जो Q1 का बेस है उसको हम ग्राउंड करेंगे. So by this way we will get the differential voltage gain. The differential voltage gain will then be equal to the output voltage divided by the input voltage. Similarly, for the common mode gain, we have to apply the input signal at both the input terminals. मतलब कि जो हमारे दो input terminals है उस पे हमने same signal apply करना होगा, तो फिर जो हमारा output voltage है divided by the input voltage, that will actually be equal to the common mode gain. So let's determine the differential voltage gain as well as the common mode gain. So for the differential voltage gain, I will apply the input signal at the base of Q1. So I can use the function generator as well as I can use the AC voltage source. So सबसे पहले मैं AC voltage source select करता हूँ. AC voltage source के लिए मैं sources में जाऊँगा, फिर signal voltage sources और signal voltage sources से मैं AC voltage source select करता हूँ. So this is actually our AC voltage source. Similarly, I have to select the ground. So this is actually our ground. So I can apply the AC voltage source by means of function generator as well as this source. Let me change its values. Our peak to peak voltage is 50 millivolts. So here I will apply 25 millivolts because this is the peak value. This is actually the AC voltage source takes the peak value, so that is 25 volt. So our peak to peak voltage will be 50 millivolts. Our frequency is 1 kilohertz, that is okay. Now control C. I am applying the AC source. I am applying the AC signal to the base of Q1 while I am grounding the base of Q2. Let me select oscilloscope. By means of oscilloscope, I can determine the input voltage as well as the output voltage. So let me use channel A for the output voltage. Here is channel B for the input voltage. Similarly, I have to ground the other terminals. So this is actually our circuit diagram. I am applying the AC signal to the base of Q1 while I am grounding the base of Q2. So in this way, I can determine the differential voltage gain. So let me run the circuit. I have to convert it into AC. Similarly, channel A is being used. Channel A is used for the output, whereas channel B is used for the input. So channel A is 5 volts per division. Channel B, let me change scale of channel B, that is in millivolts. So I will change it into 50 millivolts. Whereas let me change the time. That is okay. Let me stop it here. So channel A is being used for the output, that is blue, whereas channel B is used for the input, that is red. So this is actually the output waveform. This is actually the output for waveform. The blue waveform actually represents the output waveform. So the blue waveform actually represents the output waveform. In the start, I had told you that Q1 is called the base of Q1 is called the non-inverting input, whereas the base of Q2 is called the inverting input. मतलब ये जो हमारा input है that is actually called the non-inverting input, whereas the base of Q2 मतलब ये जो हमारा input है this is actually called the inverting input. Why? Because अभी हमने Q2 के बेस को ग्राउंड किया है और Q1 पे हमने सिग्नल अप्लाई किया है, तो जो हमारा आउटपुट है that is actually in phase with the input signal. The input signal is actually red, the output signal is actually blue, so the output signal is in phase with the input signal. So that is why we call the base of Q1 is the non-inverting input. After some time we will see that why do we call the base of Q2 as an inverting input, क्योंकि वहाँ पे जब हम Q2 के बेस पे सिग्नल अप्लाई करेंगे और जो हमारा आउटपुट सिग्नल आएगा so that will be an inverted signal. There will be 180 degree phase shift. Now here our input voltage is 48 millivolts or approximately 50 millivolts. So our input voltage is 48 millivolts, our output voltage is 3.78 volts. So the output voltage gets amplified. So our differential voltage gain will be the output voltage divided by the input voltage. So by this way we can calculate the differential voltage gain. The differential voltage gain will be the output voltage divided by the input voltage. Our output voltage is 3.8 volts, whereas our input voltage is 47.8 millivolts. Now let's suppose I am applying the signal at the base of Q2 while I am grounding the base of Q1. Now let me observe the output. If I run this circuit, अगर मैं इसी circuit को run करता हूँ, so let me I think there is some problem in this circuit. Let me run it again. The ground is not connected properly. Now I connected the ground properly, so let's observe the results now. Now if we look at the input and output signal, so the output signal gets inverted. It means that there is 180 degree phase shift between the input and the output signal. अभी अगर हम Q2 के बेस पे सिग्नल अप्लाई करते हैं और Q1 को ग्राउंड करते हैं, so it means that signal will get inverted. So that is why we call this input terminal as an inverting input terminal. That is why we call the base of Q2 as an inverting input terminal. Similarly, if I take the output from the collector of Q1, so it will get inverted. It means that if I get the output from the collector of Q1, so this will be the non-inverting input and this will be the inverting input. So by this way we can determine the differential voltage gain. Now how can we determine the common mode gain? So for the common mode gain we have to apply the same signal to both the input terminals. It means that कि दोनों इनपुट टर्मिनल्स पे हमने सेम सिग्नल अप्लाई करना होगा. जब दोनों इनपुट टर्मिनल्स पे हम सेम सिग्नल अप्लाई करेंगे, so we will get the output, and from that output we can determine the common mode gain. So let's determine the common mode gain. For the common mode gain we have to apply the same signal to both the inputs. It means that we have to apply the same signal to both the inputs. तो हम क्या करते हैं कि यहाँ पे ऑलरेडी हमने AC सोर्स अप्लाई किया हुआ है, तो हम Q2 का बेस इसके साथ कनेक्ट करते हैं. We will connect the base of Q2 to this AC source. But in common mode the input voltage is actually V1 plus V2 divided by 2. So here I will change this value. In common mode the input voltage will be equal to V1 plus V2 divided by 2. So if I have to apply 25 millivolts peak or 50 millivolts peak to peak, so how can we get 25 millivolts peak from Q1 plus Q2 V1 plus V2 divided by 2? By making this value 12.5 millivolts. So 12.5 millivolts, that is V1, plus 12.5 millivolts, that will be V2. So 12.5 millivolts plus 12.5 millivolts divided by 2. So by this way I will get the average value. V1 plus V2 divided by 2. We can use 25 millivolts, or input voltage will get increased. That is not a problem. But in common mode our input value will be equal to V1 plus V2 divided by 2. We have the output and we have the input. So let's run this circuit. Remember that in common mode the output is too much less. जब हम common mode वोल्टेज गेन फाइंड आउट करते हैं तो जो हमारा आउटपुट वोल्टेज होता है वो बहुत ज़्यादा कम होता है. लाइक यहाँ पे हम देख सकते हैं कि जो हमारा आउटपुट वोल्टेज है दैट इज टू मच लेस. मतलब अगर हम स्केल को चेंज करते हैं तो हमारा आउटपुट वोल्टेज नजर आ जाता है. So in common mode our output voltage will be too much less, like our input voltage is 50 millivolts and our output voltage is 25 millivolts. So input voltage divided by the output voltage, channel B is connected to the input, whereas channel A is connected to the output. So the output voltage divided by the input voltage. So this will actually be the common mode gain. The common mode gain will be equal to the output voltage divided by the input voltage. The common mode output voltage divided by the common mode input voltage. So by this way we will determine the common mode gain. So we determined the differential voltage gain, we determine the common mode gain. Now how can we determine the common mode rejection ratio? So the common mode rejection ratio is actually equal to the differential voltage gain divided by the common mode gain. So in this experiment we found the differential voltage gain. The differential voltage gain was equal to the output voltage divided by the input voltage when we were applying the signal at the base of Q1 or at the base of Q2. डिफरेंशियल वोल्टेज गेन फाइंड आउट करने के लिए हमने क्या किया कि Q1 पे सिग्नल अप्लाई किया और Q2 को ग्राउंड कर लिया, या Q1 को ग्राउंड कर लिया और Q2 पे सिग्नल अप्लाई कर लिया. सो वी गॉट the differential voltage gain, and the differential voltage gain was equal to the output voltage divided by the input voltage. After that we determined the common mode gain. How did we determine the common mode gain? तो common mode के लिए हमने Q1 और Q1 के बेस पे और Q2 के बेस पे सेम सिग्नल अप्लाई कर लिया. We applied the same signal at the base of Q1 and Q2. When we applied the same signal at the base of Q1 and Q2, so the output voltage was very less. So the common mode gain was then equal to the output voltage divided by the input voltage. Now how can we determine the common mode rejection ratio? The common mode rejection ratio, CMRR. The common mode rejection ratio will now be equal to the differential voltage gain divided by the common mode gain. So we determined the differential voltage gain, we determined the common mode gain. So our common mode rejection ratio will be equal to the differential voltage gain divided by the common mode voltage gain. So this was all about the differential amplifiers. If you will have any question, you can ask. Thank you.